So let us continue application of definite integration. In that exercise 5.1, the first lecture on this exercise. The first problem is find the area of the region bounded by the following curves, x-axis and the given lines. Y is equal to 2x. This is the curve. Then x is equal to 0 and x is equal to 5. First of all, we have to draw a rough sketch for these given equations so that we can conclude which area we have to find out. So y is equal to 2x is the line passing through origin and which will passes through the third and first quadrant of this xy plane. So and the x is equal to 0 is nothing but our y-axis, and x is equal to 5 is this line, x is equal to 5. So the region bounded by this curve, these two lines and x-axis is this shaded region. So this is the region which we want to find out. Now as it is the area is bounded by x-axis, so we will use the first formula, integration from a to b y dx. Integration from x is equal to 0 to x is equal to 5 y dx, as it is bounded by x-axis. Now what is y? Y will take from this curve. Y is equal to 2x, so we will take 2x. 0 to integration from 0 to 5 2x dx. 2 is constant, so integration of x is x square upon 2. So 2 will again get cancelled and we get x square only. So put upper limit and lower limit. So 25 minus 0. So area of this triangular shape triangle is 25 square units. Now the next problem is find the area of the region bounded by the following curves, x-axis and the given lines. X is equal to 2y, y is equal to 0 and y is equal to 4. So this is the region which we want to find. So x is equal to 2y is this line which passes through the first and third quadrant, and then these are the two lines. Y is equal to 0 is nothing but x-axis and y is equal to 4 is nothing but our this line. So this is the area bounded by this curve and this y-axis. So this area we want to find out. Okay, now how to find this area? As the limits of y are given, y is equal to 0 to y is equal to 4, for this problem we will use our second formula, integration from c to d x dy. As it is bounded by y-axis, we will use the formula x dy. If it is bounded by x-axis, then we will use the formula y dx. So put these limits and the value 0 to 2, 0 to 4. What is x? X is 2y. So 2y dy. Integrate with respect to y. You will get y square upon 2. 2 will get cancelled and you get y square. Now put upper limit and then lower limit. So y square, 4 square is 16 minus 0 square is 0. 16 minus 0 is 0. So the required area is 16 square units. Now moving further, the next problem is bounded by the x-axis, x is equal to 0, x is equal to 5, y is equal to 0, y is equal to 4. Just draw these 4 lines. X is equal to 0 is nothing but y-axis, y is equal to 0 is nothing but x-axis, x is equal to 5 is the line parallel to y-axis, y is equal to 4 is the line parallel to x-axis. So this is the required area which is bounded by x-axis and the lines x is equal to 0 to x is equal to 5, which is actually rectangle, and the length and breadth of this rectangle respectively is 5 units and 4 units. So what is the area of the rectangle? Length into breadth. So 5 into 4 is 20. So its area is 20 square units. Now let us check by definite integral how it comes 20 square units. So these are the two limits, x is equal to 0 and x is equal to 5. So this is the curve which bounds the area, that is y is equal to 4. So y is equal to 4, put, then take an integration, upper limit minus lower limit, 5 4s are 20. So 20 square units is the required area. Now the next problem is bounded by y is equal to sin x is equal to 0, x is equal to pi by 2. So first of all we will plot the graph of sin x. Okay, then we have given the limits x is equal to 0 to x is equal to pi by 2. So x is equal to 0 is nothing but y-axis, and this is your pi by 2. So the area is enclosed by x-axis also. So above x-axis, between these two lines and between this curve, means this is the shaded region. So the integration is now with the, as the area is bounded by x-axis, so its integral is y dx, 0 to pi by 2 y dx. What is y? Y is sin x. Take its integral. Sin x its integral is minus cos x dx, minus cos x. So lower limit and upper limit. So put upper limit minus lower limit. Cos 90 is 0 and cos 0 is 1. So 0 minus 1 is minus 1. Minus 1 into this minus is plus 1. So you get the area as 1 square units. Now this is the next curve, x into y is equal to 2, and the lines are given x is equal to 1 and x is equal to 4. As the limits of x are given, so definitely we will use the first formula, a to b y dx. Now let us plot the graph x into y is equal to 2. So its graph is like this, x into y is equal to 2, and the lines are given x is equal to 1 and 2x is equal to 4. Okay, now we want to find this area. So what is the y for this curve? Y for this curve is 2 upon x. So use the formula y dx and put the value of y 2 upon x. Now as integration of 1 upon x is log of x, so put upper limit and lower limit. So log of 4 minus log of 1, but log of 1 is 0, so log 4 minus 0 is log 4 only. So 2 times log of 4, you can keep it as it is, or you can write log of 16 square units. So this is the area of this shaded part. Now the next example is the curve is given y square is equal to x, and the lines are given x is equal to 0 and x is equal to 4. Now y square is equal to x is the parabola opening towards the positive direction of x-axis. This parabola opens towards positive direction of x-axis, and the lines are given x is equal to 0 is the y-axis and x is equal to 4 is this line. So this area we want to find out. Now this area is symmetric about this parabola is symmetric about the x-axis. Okay, you can see that whatever the part of the parabola lies above the x-axis, the same part lies below the x-axis. So it is symmetric about x-axis. So A be the required area of the parabola, then this area is given by 2 into area lies in the first quadrant. 2 times the area lies in the first quadrant due to symmetry. Instead of finding this total area, okay, we have to find this first, this area, then this area, then we have to add them. Instead of doing this area is symmetric, so we will find the area only in first quadrant and we will multiply it by 2, so we'll get the total area twice the area. So 2 times x is equal to 0 to x is equal to 4 y dx. What is y? Y for this curve is root x. So put root x. Root x means x raised to 1 by 2. Now take the integration and put lower limit and upper limit. The required area is 32 upon 3 square units. Again, we have given the y square is equal to 16x, that is the parabola opening towards the positive direction of x-axis. And the same lines are given x is equal to 0 and x is equal to 4. So again, we will say that it is symmetric about x-axis, and the is 2 times a1, where a1 is the area of the parabola lies in the first quadrant, satisfy the given condition. So a 2 into x is equal to 0 to x is equal to 4 y dx. Now what is y for this curve? It is y means root 16x, that is 4 root x. So take the integration x raised to 2 1 by 2, its integral is x raised to 3 by 2 upon 3 by 2. Put the lower limit and the upper limit, you will get the area is 128 upon 3 square units. This is the area of this shaded part. Now the next problem is find the area of the region bounded by the curves parabola y square is equal to 16x and its lattice rectum. Now we don't have given anything, just they are saying that it's lattice rectum. Now what is lattice rectum you must know. Okay, when we draw the parabola, it has a focus on its axis. Its coordinates are given by a0. The coordinates of focus the coordinates of the focus are given by a comma 0. These are the coordinates of the focus. So any chord, you know that the circle having the chords, so any chords which passes through this focal is called focal chord. This is the, if I draw this line, this is a focal chord. If I draw this line which passes through the focus, it is a focal chord. But if I draw a line which passes through the focus and it is perpendicular to the axis of this parabola, then it is called as a lattice rectum. So from this parabola, if I compare with the standard parabola y square is equal to 4ax, we will get 4a is equal to 16. So a is equal to 4. So this is the line x is equal to 4. And we want to find this area enclosed between the parabola and its lattice rectum. So again, 2 times the area lies in the first quadrant. Formula used. Take the integration and put the values. You will get 128 upon 3 square units is the area which bounded by this parabola and its lattice rectum. Okay. The next problem is we have to find the area of the region bounded by the parabola y is equal to 4 minus x square and the x-axis. What is this parabola? Okay, what is this? You may say that this is a semicircle. No, it's not a semicircle. This equation of parabola, I can write it as x square is equal to minus in bracket y minus 4. Okay, so it is in the form of x minus h bracket square is equal to minus times y minus k. So this vertex of this parabola lies at 0 comma 4. The vertex lies at this point. So this is that point 0 4 where the vertex of the parabola is present. Then we have to plot this parabola like this. We will extend to it to infinity, no problem. But we don't know from where it passes or which cuts the x-axis. Okay, now to find the values where it cuts the x-axis, we have to put y is equal to 0. Now if you put y is equal to 0, we will get 4 minus x square is equal to 0. That means x square is equal to 4. X is equal to plus minus 2. So the parabola cuts x-axis at 2 points. One is 2 0 and other is minus 2 0 as required. Minus 2 0 and plus 2 0. So we want this area which is bounded by this curve and the x-axis. So it starts from minus 2 to plus 2. Okay, you can integrate from minus 2 to plus 2. Then we will use the property which we studied, that minus a to plus a f of x dx is 2 times 0 to a f of x dx if it is even function, and it's equal to 0 if it is odd function. So it is even function, so you will write 2 times, but actually we will say that this parabola is symmetric about the y-axis. So whatever area lies in the first quadrant is the same area lies in the second quadrant. Okay, so we will find the area in the first quadrant only and we will make it twice so that we obtain the actual area. So x is equal to 0 to x is equal to 2. 4 minus x square dx. So take the integration of 4 is 4x and integration of x square is x cube upon 3. So lower limit and upper limit, put then simplify, you will get the actual area of this region or this part, that is 32 upon 3 square units. Okay, now we will stop here and we will again meet on the same exercise. We will continue the same exercise in our next lecture.